Hello everyone, today I'm going to deliver a lecture on materials of Prestress concrete or PSC. We'll see the materials of Prestress concrete. First of all, I will try to cover the concrete strength requirement for Prestress concrete and concrete strain characteristic and steel wire, steel strand, steel bar, fatigue tendon, auxiliary material such as grouting and fatigue strength. So let's start the concrete strength required for pre-stress concrete. Okay, let's see. Uh, Here is a concrete strength requirement. It is uh, taken from the design of Prestress concrete structure third edition by T.Y. Lin. Okay, so let's see concrete strength requirement. Okay, so you can see here the present practice for 28 days cylinder strength 28 to 55 MPa for Prestress concrete, which is RCC is around 24 MPa. And second one, the usual cable strength specified for the Prestress concrete in Europe available 45 kg 450 kg per centimeter square based on 10 centimeter, 15 centimeter and 20 centimeter cubes at 28 days. And third one, you can see the if the cable strength is taken 1.25 times of the cylindrical strength. So cylindrical strength uh, 35.5 pmp. As we know, the cube strength. These are the cube like this. Okay, and the cylinder, we know the cylinder will be like this. The cube strength is taken 1.25 times of the cylinder strength. 35.5. And another one we can see 28 MPa to 34 MPa will most economical for Prestress concrete. These are the double star. So 24 MPa to 41 MPa of concrete strength can be obtained without excessive labor or cement. And another we can see the cost of 41 MPa concrete average 15% higher than the 21% of concrete, while it has 100% higher strength. Okay, another one we can see 41 MPa to 55 MPa will sometimes be specified for precast, prestress and concrete beam. Another one we can see to attain 34 MPa, it is necessary to use water cement ratio not much more than 0.45 by wire basis. So you can see 34 MPa for attaining 34 MPa. So we are use water cement ratio. We can see 45.45. Another one we can see the slump of 50 millimeter to 100 would be the needed unless more than ordinary vibration to be applied. Another one we can see here double star to obtain 76 millimeter slump with water cement ratios 45 as we have been seen in previously uh, would require about 4 bags of the cement per cube yard of the cement. Okay, last one we can see the carefully vibration is possible concrete with 13 millimeter to 0 slump can be employed at 7 days of cement per cube yard may be good for sufficient. Okay, these all are the concrete strength requirement. You can if you go to the design of Prestress concrete third edition TY lean, then you can easily see here is the right hand just these are the concrete strain. Okay, these are the not strain, these are the concrete strength. So I have been taking from 28 this to 22. So I have been taking from all the information taken from this slide, from this slide. Okay, let's see another. These are the completed. Another concrete strain characteristics for Prestress concrete. Let's see. I'm just using this book from TY Lim. So you can see here concrete Prestress concrete here. If you go to the here, I'm also taking the same. The concrete strain characteristics. The elastic strain. The strain elastic strain is part of the little ambiguous since the strain curve for concrete is seldom. The straight line is normal level to the stress. Figure is given here for 2.1. The typical stress strain curve in 5000 PS, which is 34 Newton MPa 1 Newton per universal concrete, as given strain is x-axis and y-axis is the stress. As we've been seeing the strain, the maximum stress have found 5 ksi at strain when 2.5. Okay. Neither are the strain are recovery, but the eliminating the creep strain from the considering the lower portion of the instance of the strain curve being relatively straight may be conventionally called elastic. These are the elastic you can see. And the modulus of varies from the several factor noted that the strength of concrete at the edge of concrete and the property of the concrete and cement and the definition of modulus of elasticity itself, neither tangent initial or second modulus. And furthermore, the modulus may be vary with the speed of the load applied on the type of specimen. Okay, so we can see here the modulus of elasticity as the SCI quote the requirement from concrete specific empirical formula being in EC W 1.5 into 33 root over F prime C. The where the unit weight W varies between 90 to 155 pound per feet cube, or we can if you see 1443 and 2483 kg per cubic meter. It is the unit weight. You can say W, the unit weight of the concrete, to the power 1.5 and 33 F prime C. F prime C the concrete strength. And the normal weight concrete, this express may be simplified as EC equal to 5700 by F prime C. As conventionally, I have been using this formula for practicing purposes. Professionally, I have been using this formula for getting the modulus of elasticity in concrete. And another, we can use the empirical formula proposed by Janssen, which is EC equal to 6 into 10 to the power 6 divided by 1 plus 200 over F prime C. Which is given the more correct value for F prime C around 500 psi or 34 MPa or Newton per millimeter square. And third one, we can see C, the empirical formula proposed by Hangnested, which is equal to 180000 plus 460 into F prime C. Okay, so in this way you can found is the concrete strain characteristics. It is completed. Now we'll see the steel wire. Okay, let's see the steel wire. Steel bar. This is the steel wire. It is also taken from the design of Prestress concrete, third edition TY Lim. So let's see steel wire. Wire the pre-stressing generally can from ASTM specification N421 for uncoated stress relation relieved wire pre-stress concrete. Okay, second one, we can say that typical stress strains curve for a stress reliever on 12.7 millimeter wire conforming to the ASTM 421 with the typical modulus of elasticity is 200 into 10 to the power 6 MPa. And third, we can see the specified minimum elongation is 245 millimeter is 4%, which is the typical elongation of rupture is more likely from 5 to 6%. This is the steel wire characteristics we can see here. So here we can see strain x-axis and y-axis is strain. As if you go to the if we go to the wire, this is the steel wire. Okay, if we go to the this book, chapter 2, steel wire, where just give me a little bit time. Steel for stressing. This is the steel wire. Okay, so we've been seeing this diagram. So there is no good diagram is given here. So I'm reading from here. So you can see the unit strain inch per inch in x-axis and y-axis, and tensile stress as we've been seeing here. 1/3 inch 5-wire stand. We can see the more more stress is given here. These are the strain also gives the maximum strain is about 2.06. And another one we can see 1/3 in inch wire. We can see here also given the 7 in the second stress. It is also is less than the higher strain, and both are the we've been seeing yield strain by 1% in elongation method. We've been seeing here 1% here, as we can see is intersecting here. Another one we can see 1/2 inch to 1/4 inch in bar. These are the given the stress is maximum stress about to the 150, and the strain is about 2.45 or 5%. Okay, these are the steel wire in that. So now you can see the steel stand. Okay, if you go to the this book steel stand, these are the steel stand. We can see here the standard for pre-stressing generally conform ASTM specific and specification F416 for uncoated 7-wire stress really built for pre-stressing concrete. 2 graded are available, which is 250 KSI and 27 KSI. If we count in MPa, which is 1724 MPa and 1862 MPa. These are the 2 graded are available. So we can see these are the steel stand. So in professionally I have been found I have been using 1862 MPa for steel stand pre-stressing generally conform ASTM specification. The uncoated 7-wire stress reveal 1862. If you go to the another calculation is given like this way. 12 TM3 and is diab strand, and 12 is how many stand we have been used. As we go to the here where this is the properties, which 1862 MPa. The tensile strength of pre-stressing is still MPa 1860. So if we go to the 1862 MPa, these are the taken from here, and modulus of elasticity is given, and yield stress all are the data taken when calculating required number of tendon. I will show another day how we calculate this. Okay. Okay, now go to back to the here. These are the steel stand. So uncoated 7-wire, we have to remember uncoated 7-wire is still rebuilt for pre-stressing concrete. 2 grade are available, which is 250 KSI and 27 KSI. In professionally I have been used 27 KSI, which is 1862 Newton per millimeter, where the grade indicate the minimum guarantee of breaking stress, where this specification were intended to pre-tension bonded and pre-stress concrete construction. They are also applicable to post-tension construction, where the bonded are in the unbonded type. These are the 7-wire strand will have center wire is slightly larger than the 6-wire, which is enclosed tightly in hicks with uniform pitch between 12 to 16 times of normal diameter of the stand. Okay, so we can see 7-wire stand commonly used for pre-tension conform ASTM 7 ASTM F416 specification, having guarantee the minimum ultimate strength, as we have been seen PSI, then if we count in KSI 250 KSI or 27 KSI, or if we count in MPa or Newton per millimeter square, is 1724 MPa or 1862 MPa. I have been using this in professionally. When we design the bridge, then it will be used professionally for Prestress girder bridge. Okay, so ultimately we've been seeing here the 7 stand and commonly used in Prestress conform ASTM 416 is 1862 millimeter. The properties of listed in table is given 2.2. These are the 2.2 I have been seen here. So if we go to the table, so let's go. The nominal diameter is given here. The breaking strength in kilonewton is given here, and nominal area of stand is given here, and the minimum load at least 1% extension is given here. These are the all are given 250 KSI, and these are the 270 KSI, and we've been used professionally this stand. That's why we've been seeing here the properties of uncoated 7 wire stand rebuilt in stand ASTM F416. If we use the nominal diameter is used 0.37 inch, or if you count in millimeter, which is 9.53, then it will be 102 kilonewton, and millimeter will be 54, and the kilonewton will be 87. Okay, I hope that it will be covered steel stand. So now we'll see the steel bar. How we'll see the steel bar. These are the steel bar. So it will also taken from here. The steel bar is given as ASTM specific on shown AR332 and AR29 are often applied to the highest strength allow the steel bar. It is usually required that the such bar is proof the stress to 90% of the guaranteed ultimate strength, although the actual ultimate strength is often reach the 1100 MPa. The specification minimum is generated set by 100 MPa, and last one we can see the typical stress strain curve for the this bar, from which can be noticed that the constant modulus of elasticity exists by only for a limited range, which is up to about 550 MPa stress, which is a value between 172,000 and 193,000 MPa. Okay, I hope that this also steel bar also completed. So let's see the tendon. It will be fiberglass tendon. Okay, as usually we go to the this book, T.Y. Lim book. I'm just referencing here the steel bar. I have been taken this all the information here here steel bar. That's why I'm not reading again. The fiberglass we've been seeing fiber tendon. The fiberglass tendon we've been seeing is manufactured by drawing the fluid glass into the fine filaments. The possible use the fiberglass of Prestress has used been under investigation for the some years. Although the fiberglass has not even the commercially applied in Prestress concrete construction, it is possesses the certain superior quantity that is indicate higher promise for prestressing, and ultimate tensile strength is given is here 6895 MPa, and all the information given here. Now we'll see the another here. We can, if you want to the tendon. What is the tendon? Tendon is nothing but this is the tendon. Tendon are highest tensile wire available in various diameter, with from 1.5 meter to 8 meter. Table is given to the ultimate tensile strength of the steel wire used for the pre-stressing. Here the diameter will be given in first column, and second is ultimate tensile strength is given here, and this is the tendon. Okay, so now see the auxiliary grouting. Auxiliary materials is such as grouting. So although here it is also taken from TY Limbo. uh, among the special auxiliary material required for pre-stressing concrete are those for providing the properties of conduit and tendon. The pre-stressing is no such conduit are necessary for pre-stressing. There are two type of conduit, one for bonded, another is unbonded pre-stress. Okay, so all the information, another information is given here. I'm just skipping another. These are the index. So another last one we can see the fatigue strength. What is the fatigue strength? The fatigue strength is pre-stress concrete can be studied from three approaches. Okay, so these are the concrete itself, the highest strength is steel and that of the combination. It may be also studied utilizing for our knowledge of the fatigue strength and reinforcement concrete. Since so much data has already been accumulated, there are however some difference between pre-stress and reinforcement concrete. For example, is given the pre-stress concrete is comparison in the extreme fiber is frequently near to zero under dead load and increase to the maximum under the live load. Thus, the bearing though throughout the wide range. Therefore, the highest strength still is pre-stressed to high level, while it is stress range is relatively small. Okay, so you can see here the for pre-stressing member under the action of design live load, the stress wire is seldom increase more than 69 MPa from their effective stress about the 1034 MPa. It is safe. It is safe to say that so long many concrete is had cracked and little is possible fatigue failure is still and through the working load exceeding a and so many information are given here. So I am just skipping here the another diagram is given here. So the today's lecture is in that this is the basically theoretical. All the lecture is theoretical. I am just summarizing the materials of pre-stress. Materials of pre-stress, which kind of material, the concrete strength will be required for pre-stress. I'm just giving some summary. Concrete strength required. So we've been seen here the concrete strength as we've been seen. The lots of data is given. If we 28 MPa to 30 MPa, the economic for pre-stress concrete, it is a point. Another point we have been used water cement ratio. Here the cost cost of 45 MPa is average 45 higher than 21 MPa concrete, while it is 100% higher strength. Another one, and to obtain from 76 millimeter some is water cement ratio 45 would be required for 8 bags cement per cubic yard of the concrete. These are the requirement of concrete strength requirement. Another we can see the strain characteristics as it is taken from this book. If we go to the previously, then we can see this is the concrete strain characteristics as we've been seeing here. The modulus of elasticity we have been taking 5000 for I have been used professionally, but you can use this and this formula also. And another we can see the steel wire. These are the important because I have been using during the bridge design of RCI girder. These are the taken steel wire. So if you go to the here the steel wire stressing, these are the steel wire we've been seeing here. Lots of the data are given. These are the not sorry. These are the not important. So we have been taking this diagram. The important is these are the steel wire, steel stand. these are the important we've been using during the eye girder bridge. Then it is taken the slow strand. So we've been seeing the uncoated the material will be used stand for generally conform STM specification 416. Uncoated 7 wire strand for pre-stressing concrete. Two grade are available, which is 250 and 270. I have been using 270, which is 162 Newton per millimeter square. I'm just using bridge design, so I'm just showing here a design of the pre-stress eye girder bridge. Number of tendon, how many number of tendon is required. So at first I have been calculating here and here and there, and after that I have been saying how to note it here, as we have been 12 T 13. 12 means how many stand we have been used, and 30 is the diameter, and initially we have been assume number 5 tendon we have been used, that's why we have been taking the number 5. In the sequentially we have been shown first of it is greater than beam, then less than cable, then less than stand, then less than wire, and then we have been we can calculating here for eye girder which we have been shown the figure like this, and cable profile 1 2 3 4 5 sequentially, and for both jacketing here, and these are the finding number of tendon, and how we have been use FS value. How will get this FS value? These are the FS value. The tensile strength of pre-stressing steel FS value. It is taken from here. These are the I want to see here, and modulus of elasticity is given, and FY. Now all the data am given, and in this way have been initially required how many number of tendon we have been found is 4. Okay, these are the not. These are the important, and then we've been seeing steel bar. So then we've been going to the steel bar. These are the steel bar. The specification is given here. Other we can use we can see this information, and then we have been shown the fatigue tendon, and I am showing what is the tendon and diameter of tendon and ultimate strength also. And last one we've been seeing grouting and fatigue strength. So grouting, these are the grouting we've been seeing here, and last one fatigue strength. Okay, so I hope that you can find everything. If you have any question, then let me know. These are the theory based, that's why it will be boring, but if you want to acquire the knowledge, then you have to start. Thank you everyone.